Our project is hand gesture recognition using convolutional neural networks. This is divided into 4 modules. So the first module is data collection. For that, first we will provide a folder name for each class. Like for first, we will collect the data for class 1. We will run this Python file using Anaconda command prompt. First, we will activate our environment on which we have installed all the libraries that are needed for this project. As we can see, there is no folder here with any class name. We will run this file and it will create the folder class 1. It is now calibrating the background and we will start collecting the data after the calibration is completed. Okay, now we can start collecting the data. Now the data is being collected into the folder. We can use different variation, different lighting for enhancing the collected data. So here we can see the data has been collected. So we have collected around 1600 images with a lot of variation. But this data is mostly raw and most part is not useful for us. So we will apply various image processing techniques to enhance data and so that we can feed it to the neural network. For that, we will run the data set preparation file. And give the address for the class folder on which we have to apply the image processing. As you can see now, it's raw data, and when we run this file, all the images are converted into threshold images, and also the extra dark region has been dropped, and they are ready for feeding to the neural network. So for training, we have used a Jupyter notebook. We have imported all the necessary file. We have provided the folder name, dataset, validation, and test set. And then we feed the training data, the validation data, the test data, and these data are loaded. And this is our architecture of our neural network. So we are using 20 epochs. The batch size is 32. So at the end, we have got an accuracy of 98%. On plotting, we can see that validation accuracy is nearby training accuracy and it doesn't look overfit. So we can test on test data, and the accuracy on test data is 98.5%. And then we print the classification matrices, and we can see that we have got an F1 score of above 96 for each of the class, and then we have printed a confusion matrix. So our test data contained 2000 images, 200 images per class. As we can see here, most of the classes have been easily recognized with 100% accuracy. Some classes have been showing similarities, like enter class, where out of the 200 test images, 187 images have been correctly identified, but 10 images have been identified as maximized. And also the volume down part is similar to the next. And this confusion matrix suggests that this model is capable for a very greater number of gesture classification. And now in our fourth module, we have created a user interface application so that we can interact with our system and use this model. So this application loads the model H5, which is saved after the training, and then take the info from the backend and classify the gestures. And on classification of gestures, a specific command has to be executed. As we can see here, it will recognize the gestures and execute the command for this volume up, and we can see that volume is increasing. This is volume down, and we can see the volume reducing. Now and this is for spacebar. This is for maximize. This is for minimize. This is for previous. This is for next. This is for close. That's it. Thank you.